Background on myself, I am the UAS business development lead here at Duncan, in charge of the entire geospatial territory for providing UAS products to our clients. So today I also have that'll be co-presenting is Matt Rosenbaum. Matt Rosenbaum is the Eastern U.S. sales manager for Microdrones. We work very closely together here, and Matt's going to be able to go over workflow and help answer any questions that any of you have that are attending today. I will ask if for any questions that you have, just please type them in the chat area, and we're going to try to have a Q&A session towards the end of this presentation. And we will try our best to answer as many of those questions as we can. So without further ado, I want to hand this over to Matt. Matt, take it away.
Hey, Miles. Thanks, buddy, for the introduction. Like Miles said, my name is Matt Rosenbaum. I'm the sales manager here for Microdrones for the Eastern United States. So essentially from Wisconsin down to Texas and on over, all the way up into Maine and down into Florida. So I've been working with Microdrones for the past, working for Microdrones for the past 4 years, and previous to that, I actually worked for a reseller of ours. So I've been around the product for close to 6 years now. I'm based out of Atlanta, Georgia. I've been in the surveying and mapping industry essentially my whole career. So I'm the son of a surveyor. I graduated college and got into the industry, and I've always kind of been around all the cool toys and gadgets that surveyors use from a young age. So I know how to speak the language somewhat, and I know how to make sure I can show you all what y'all are hoping to learn about our products today. I've done a lot of these presentations, so I'm gonna get going and make sure that I touch on the things that I think that y'all are hoping to hear. But yeah, like Miles said, if y'all have any questions, please save them for the end of the presentation, and we'll try to get to as many as we can. So without further ado, talk a little bit more about Microdrones. I know we might be a new manufacturer for some of y'all here. Microdrones is actually one of the oldest commercial UAV manufacturers. We actually released the first commercially available quadcopter in the early 2000s. At that point, people would come to us with various payloads and things they wanted to carry from the systems, and make little one-off products for each one of those customers. It's not a very sustainable business model. So over the last 7, 8, 9 years, we've shifted away from that focus to really focus on the surveying and mapping industry. So much so that we don't really brand ourselves as a drone manufacturer. We sell survey equipment. And what that means is we don't just sell a drone or just sell a payload or just sell the flight planning software or everything in between. We control that entire workflow from planning the mission to integration of the survey payload, be it a photogrammetry or a LiDAR-based sensor, the flight planning software, the post-processing software, everything in between. So you have that one manufacturer to go to for service support and everything, the whole 9 yards. Everything is kind of under the MD Solutions umbrella, with the main focus today being on the MD LiDAR and MDMapper line. We also have an M detector line for doing various GIS tools like methane gas inspection and whatnot as well. As far as the manufacturer goes, we are a German-based organization. We have offices in Siegen, Germany, as well as Canada, and then here in U.S. in Rome, New York, but also down here in Atlanta, we just opened up an office just outside of Alpharetta. So we have the people in place and the dealers in place to make sure we're there to support our customers, all around the world, all around the country, and throughout the Duncan territory. So, from, the survey side, I always like to talk about mdCockpit before we hop into any of our different survey payloads, because this is kind of the central nervous system that makes these sensors go, these systems go. mdCockpit is the flight planning software that powers all of our different geospatial tools that are flown from the drone. The big thing that you'll hear me talk about today is the word integration, because integration is kind of what sets our products apart from our competitors. Because we integrate the payload and we're able to integrate it in with the airframe, we're able to do a lot of things that other people can't. So if you take, for instance, this survey polygon that you see here, the drone's actually going to be manipulating the scanner throughout the entire flight if you're flying a LiDAR mission. So for instance, we'll actually fly an alignment waypoint. We'll get feedback from the scanner once the IMU is aligned. See these using very precise IMUs on board the system. When they start to enter the survey polygon, it's actually going to turn the scanner on here turn it off here, turn it on here, turn it off here, so on and so forth throughout the entire mission. So you're actually separating those LAS files into strips, so you have them separated from the flight plan. You're only actually gathering the data that you want. So whereas our competitors have, you know, a black box solution that you'll turn the scanner on before you take off, turn it off when you land, and you have one giant file to go in and clean up after the fact. So this allows for you to be much more precise in the area that you're trying to capture, only gathering the data you want, so you can spend less time cleaning up that data back in the office. The other thing too is throughout that flight, you're getting that feedback from the scanner throughout the flight. So it's letting you know what your GNSS is doing, and, you know, making sure that it's logging data like it's supposed to. When your IMU comes aligned, you'll see this go from red to green. So it's giving the pilot peace of mind that everything's working like it's supposed to. And it's also going to go from ready to scanning mode. So when the scanner actually starts to scan, you'll see it, and it's giving you information, letting you know that everything's working again like it's supposed to. You know, all of our different sensors and imagery, photogrammetry payloads are all built into this software. So as you're actually, you know, planning your mission, you select the one that you're looking to fly, and build your mission based upon that. Be it a survey polygon that you can draw on the screen with your finger like this. You can also import KMLs and fly corridor mapping missions like you see here. So it's all very dependent on your preference. But if you need to be more precise in your planning of your mission, you can actually import those KMLs to actually use as references like you see here. So you can actually have that KML of the center line of the corridor like you see here. You can also use that KML to actually build your mission, tell it how wide your corridor is, how much overlap you want, and it'll actually build your mission that way. And then finally, you can actually use those as references. So if you wanted to have a boundary like you see here, where you don't want to fly, or if your takeoff point, you can have that polygon set on the screen, and also different things that you might be crossing like a pipeline. So you can use and actually import the line work for that particular job that you can reference and make sure that you're planning your mission in the most efficient manner and just like you would like to. Another cool tool that we just released with mdCockpit is you know, being able to see your terrain model while you're planning your mission. So you can actually use what's called terrain follow with our systems, especially important when you are flying with LiDAR payloads and photogrammetry payloads to keep a constant point density or a constant ground sampling distance of your imagery. You'll want to keep a constant height above the ground. So in this case, if you were flying a mission over these mountains and you set your mission to fly 50 meters above your takeoff point, it'll fly 50 meters throughout that entire flight, and the software is going to let you know, hey, in this area, you got to be careful. It looks like you're going to run into the ground. So in that case, you know, it's giving you updates, letting you know that, hey, you know, you make sure you don't plan your mission like this because you might have an incident. So you can actually use terrain follow using that terrain model to actually plan the mission, and the drone will actually keep that constant 50 meters above the ground throughout the entirety of this whole flight, like you see here. So just another cool safety tool, but also it's going to help give you more accurate data and keep your data consistent and precise because you're actually flying it and gathering the data in the most efficient manner and the way that you need to make sure that your data is usable. Before we hop into actually the hardware, we actually had a pretty big announcement earlier this year with General Electric. So General Electric spent the last 4 or 5 years kind of diving into the UAV industry, wanting to make a splash in this industry. And after their research and looking at different manufacturers, they decided to partner with Microdrones. So actually our new MD4 1000 product line is actually all branded the GE industrial drone line like you see here. So GE is now an investor into Microdrones, has a member sitting on our board as well. And you know, brings a lot of credibility to our company and also brings a lot of credibility to our end users because, you know, when flying critical infrastructure like power lines and right-of-ways and stuff like that, that might have things that you want to make sure you're being safe over, you know, having a system that those types of facilities are familiar with helps bring, you know, even more credibility to our end users as well. So that you'll see the 1000 product line is the GE industrial drone line. The 3000 product line, which we'll touch on at the end of the presentation, is the Microdrones expert drone line. So still keeps the Microdrones name. I always like to talk about the MDMapper 1000 DG before we hop into the LiDAR side of things, because this is the system that really put Microdrones on the map. And it also allows for me to kind of explain what DG is and direct georeferencing. So like I said, DG stands for direct georeferencing. And what that is essentially a marriage between a post-processed kinematic GPS and a very precise IMU. So as we're flying, we're not only getting, you know, the exact lat long altitude of each time the camera takes a picture, but also how that camera was orientated. So the omega phi kappa angles, or the roll, pitch, and yaw angles of that particular sensor. Because we do actually get this information in the sky, we essentially know where each pixel is orientated on the ground before we even process any tie points through a photogrammetry software. So the big benefit with photogrammetry is that we can actually fly less flight lines, fly with less overlap. So we're taking less pictures, and we're more efficient in the sky from that particular mission, taking less pictures, but even more so, more efficient back in the office, taking less pictures to actually process through a photogrammetry software. Because I assume many of you know, with photogrammetry, it can be very time-consuming, stitching thousands of photos together. So the more you can minimize the amount of photos, the quicker you actually build a deliverable. I tell you about this technology because, direct you're referencing, it isn't a new technology. It's essentially scaled down how it's done from traditional manned aircraft. And with LiDAR, it is a necessity. And with photogrammetry, it's really nice to have, and it helps increase the efficiency. With LiDAR, you have to know how that particular scanner is orientated throughout the entire flight. So the DG, and the science behind it really allows for this. It's got a 42 megapixel camera. Being able to fly a couple hundred acres in a single flight and produce very high resolution imagery, a 1.6 centimeter GSD at a 400 feet flying height with this system is going to allow for you to produce very high quality orthos to deliver to your clients. But as many of you know, with drone technology, the conversations have kind of shifted over the last couple of years from photogrammetry to LiDAR. And one of the biggest reasons for that is, like I said earlier, the workflow and the time, it takes to actually process that data. So one of the biggest things that I see people looking to go to LiDAR is because of that workflow and how time consuming it can be. You can actually go and, instead of taking, spending, less time in the field, but when you get back in the office, spending much less time processing the data, producing a point cloud, can all be done within 15, 20 minutes versus letting your computer run hours and hours to stitch photos together. The other thing where photogrammetry fails is, in high vegetation, it sees the trees as the ground, whereas LiDAR gives you ample opportunities to penetrate through that vegetation, get shots on the ground, build surfaces under that vegetation so that you can then go and build your surfaces, build your 1 foot contours under that vegetation. Because not everybody enjoys cutting line and spending hours and days and weeks in the jungle, traversing with your total station and everything. Being able to go in and scan a 20-acre site within 15, 20 minutes, produce your contours, really becomes allows for you to go and do these types of projects much more efficiently in the field. The customers, I've sold a lot of these over the last couple of years, and the customers I've seen had the most success, aren't the ones that go try to reinvent the wheel with this technology. But how can you become more efficient in your current workflows by implementing this technology in your day-to-day stuff? Go from doing one of these types of topos every couple of weeks to doing one of them a day. Because you can increase your time, decrease your time in the field and in the office. You can increase your return on investment or increase make your much quicker return on investment because you start to win more projects, you start to complete more projects more efficiently. So that's the biggest thing I try to tell people when I'm educating about this technology is, really try to look at how you can go and implement these types of systems in your day-to-day work and decrease your time in the field. It really helps start to win more projects. The next thing really is, when you are looking at various UAS LiDAR-based systems, there's some things you should really pay attention to. The first thing being is what the workflow looks like. As I stated earlier, Microdrones controls that entire workflow. So that means from the flight planning, the drone, the payload, the flight, the production of the LAS file after the fact is all done through a Microdrones workflow. So that means if you need service support training on that workflow, you have one manufacturer to call or one dealer. You're going to call Miles and the team at Duncan-Parnell, and they'll be able to help you with all facets of that workflow. Whereas our competitors, you have somebody integrating a LiDAR payload, somebody building the drone, somebody doing the flight plan software, somebody doing the post-processing software, and you start to introduce 4 or 5 different hands in the fire when it comes time to get support. It's a lot of times you don't know who to call. So having, you know, the team behind you that you know that's there to support you on that entire workflow is really powerful, because this is advanced technology. There's going to be a learning curve. You want to make sure that you have a team behind you that can help you in all facets of that workflow. The other thing being is the inertial navigation sensor or the IMU on board. You know, it doesn't matter if you got $1 million LiDAR scanner in the sky. If you don't know where that LiDAR scanner is in 3D space at all times, your data is going to be garbage. So making sure you utilize the best you know, IMUs for that particular scanner to make sure you can get the most out of that particular system, giving you the most accurate data possible. So we utilize all the Trimble and the Planix IMUs on board our systems to make sure that, you know, the 1000 and the 3000 product line is given the best quality data for those particular systems. Another thing being is a LiDAR sensor with multiple returns. So as we discussed in the previous slide, a lot of cases people are looking to utilize these types of systems in a high vegetated site. So having a sensor that can give you multiple returns, you know, at least minimum of 2 with a high point density, and above that is going to give you ample opportunities to penetrate through that vegetation, get you shots on the ground, produce surfaces under that tree canopy. And then finally, you know, a system that can really grow with your organization in low maintenance. You know, the MD4-1000, which we're talking about right now, is actually 13 years old this year. It's not the same drone we released, you know, 13 years ago, but our customers have constantly had the ability to continue to upgrade, you know, as we grow. So having, you know, peace of mind that, you know, you make an investment in these types of systems, you know, you can continue to work and grow, you know, as we grow. You don't have to worry about that system becoming obsolete, you know, soon after. And the other thing being is that strong training and support network. Like I said earlier, it's very powerful having a team like Duncan behind you. You know, you're going to get the same level of support on the microdrone side from Duncan-Parnell like you get on the Trimble side. So I know many of you have been a Duncan customer for a long time, and that's one of the biggest reasons for it. Well, Miles and the team at Duncan are going to make sure that you're getting that same level of support with these systems, because it is, you know, advanced technology, and having that peace of mind, having that team behind you to make sure you're successful is going to be hugely beneficial for you. So the first system we'll talk about is one of our newest products, the MD LiDAR 1000 HR. HR standing for high resolution. You know, this is the second generation of our LiDAR 1000 product line. You know, the first generation system we nicknamed the 1-foot contour generating machine. This system is very similar to that. However, it's going to give you higher point density, a little bit more precision as well, and can cover more ground. So I call it more than 1-foot contours, because it's also giving you even more precision data on the facades of buildings and structures and power lines in many cases. It utilizes the Velodyne Puck VLP-16 as well as the APX-15 gene assess and IMU from Trimble and Planix. The workflow is very similar. That all of our systems have. You plan your missions through our mdCockpit software, and you'll do the post-processing in our MD Infinity software. It has a 6,500 gram takeoff weight, so right about 14 pounds, and can fly, you know, on average, you're going to get 25 to 30 minutes of flight time, in some cases even more than that. But I would say most of the time people are getting about 75 acres or so on average of coverage in an area style mapping mission. It has a 4-centimeter RMSE as well, so the X, Y, and Z, and can produce, you know, a little bit of everything. But in many cases, people are using this for your terrain mapping type missions. The cool thing about these tables that you see here, and I'll explain a little bit more, but they're actually all integrated into mdCockpit. So with LiDAR, coverage and point density all depends on how high and fast you fly. So the higher and faster you fly, the more coverage you're going to get out of that particular system. The lower and slower you fly, the more point density or more detail you're going to get on that particular flight as well. So finding that happy medium of what you're looking to fly and map really helps increase, you know, your efficiency in the field and getting the data you want the first time. Typically, I would say people are flying about that 50 to 60 meters or 200 feet above the ground, and about 4 to 5 meters a second, or about 10 miles an hour. Now, in those parameters, you're going to get anywhere from 60 to 80 acres of coverage in a single flight. The HR does have a 5-megapixel camera on board, so it's actually gathering imagery and LiDAR at the same time. The images from the HR payload are going to give you about a 4-centimeter per pixel or better imagery. And in most cases, this camera is really just designed to colorize the point cloud, but it can produce an ortho if you are looking to produce an ortho with this system. Next being our MD LiDAR 1000 LR, LR standing for long range. So this system utilizes the Velodyne Puck 32 as well as a 26 megapixel camera. So in this case, you're getting both high resolution imagery and the high density scan data from the scanner. You can fly this system up to 120 meters or 400 feet, whereas we're flying the HR about 60 meters. So it's not as powerful, not as dense on the HR. This one we're looking much denser and also able to get the high resolution imagery in the same flight. Same accuracy specs. It actually is about 100 grams lighter. So again, you're going to get 30 minutes, 25 to 30 minutes of flight time with this. I had somebody land the other day about 33 minutes of flight time and never even hit low battery. So you can get quite a bit of coverage with this system, especially knowing that you can fly up to 400 feet above the ground. Again, same thing, the higher and faster you fly, the more coverage, anywhere from 100 to 200, in some cases, even more acres of coverage in a single flight. But it's all dependent on what you're trying to map. If it is super dense vegetation, you might want to slow it down. If it's wide open, you can let it cook and fly fly high and fast. But both of these systems have a 90-degree field of view of the scanner that we're typically mapping at. So essentially, if you're flying at 100 feet, you're going to have a 200-foot wide swath. If you're flying at 400 feet, you're going to have an 800-foot wide swath. So you can cover quite a bit of land with that swath of LiDAR data as you're progressing forward. Next, we can talk about the Microdrones expert drone line. The MD LiDAR 3000 product line utilizes the Regal scanners as well as a more precise IMU. It's actually a dual IMU from a Planix to APX20, and I'll get into that a little bit more. But the first system we can talk about is the MD LiDAR 3000. This actually utilizes either the Minivox 1, Minivox 2, or Minivox 3 from Regal. It also has on board 42 megapixel camera, so the Sony RX1R2 camera that is on our DG payload is integrated into this system. So you're getting both the high accuracy scan data and the high resolution imagery within the same flight. It has about a 15 kilogram takeoff weight, or about 33 pounds, and a much more precise data set. So this system can do everything the 1000 can do and a little bit more. So this is going to be for your more if you're doing power line work, if you're wanting more precise data on roadways and structures and stuff like that, where you need the tighter accuracy, that's where the 3000 product line really shines. Same thing, workflow wise, mdCockpit to plan and fly your missions. You process the data through our MD Infinity software. And then we have what's called our vertical feature configurator, and I have a slide that'll touch on that as well, but you can actually configure the Minivox line as well as the Vux 1 system that we have as well to actually scan various structures and whatnot, in a more efficient manner. The big benefit of our MD LiDAR 3000 product line is the way we actually connect the system, as well as the integration of the payload and the IMUs. So as I stated earlier, the APX20 is a dual IMU solution. Because Microdrones actually builds the drone and integrates the payload, we're actually able to separate the IMUs. So we actually put the APX20 board on the drone and the IMU82 on the back of the payload. So as we're flying, we're actually getting data on how the drone's roll pitching yawing throughout the flight, as well as what the payload's doing, how it's roll pitching yawing throughout the flight, allowing us to get a more accurate trajectory or more accurate SBET than our competitors, because we're compensating and understand the distance to our lever arm distance to our GNSS on top of the drone in a more precise manner, because we actually are compensating for all of those pieces working together. We also don't have any cables or anything to actually have to hook up with these things. We have a quick release mount where these 4 posts actually connect right into the bottom plate of the system, and there's no coax cable or anything going down to the payload, or no batteries, just like the 1000 that we have to hook up to the drone in order to get everything working. Installing the payload is as simple as this. Uninstalling it the same way. So essentially, you take the drone out of the box, you put the arms on the drone, attach the payload, turn it on, and you're ready to start flying. So the setup time and everything is very quick with the MD LiDAR 3000, as is on the 1000. But this advancement in the way that these sensors actually connect to the drone and work together, really what sets us apart on the expert style of LiDAR scanners for UAVs. So the Minivox 1 that we just talked about is a great kind of all-around scanner. The Minivox 1, 2, and 3, has different pulse rates. The Minivox 3 is the main system we're selling now. It's the newest Regal scanner. It has up to 300 kilohertz at a 360-degree field of view. Typically, we're mapping between 90 and upwards of 110 degrees with that scanner. The Minivox 1 DL that you see here is actually an ellipsoidal scanner. So if you can see my mouse, as you're flying, we're actually only scanning like you see here. So it's a really, really dense scanner. It's 100,000 points per second, but all 100,000 points are going down to the ground at a 46-degree field of view. So this allows for us to map things like power line corridors and pipeline right-of-ways super efficient and get very dense data. In a lot of cases, we might get 2,000 points per square meter where those scan lines overlap on the edges. So this sensor is great for corridor mapping, and if you wanted to map, structures, smaller areas that might have, you need a lot of detail on. It is a little bit heavier than the Minivox 1, 2, and 3. So you're looking at about a kilogram heavier, about 2 pounds heavier. So you get a little bit less flight time with this than you would the others. However, most of the time people are flying long, straight right-of-ways with it for corridor mapping, and you're going to get very good flight times with it, about 20-25 minutes or so. Lastly, we have our MD LiDAR 3000 LR. So this actually uses the Vox 1 UAV. The Vox 1 UAV is a heavier scanner from Regal. So we don't have a camera integrated with it at the same time. However, we can fly it, easily at 400 feet above the ground, and in some cases even more, depending on what you're mapping and the waivers you can get with that system. But it is got a very dense and long range. So if you're flying and mapping power lines or mapping areas with a lot of terrain relief, or if you just want to cover a lot of ground, you can put it up at 400 feet. Which under Part 107 is what you need to keep it under, and you can cover a couple hundred acres easily in a single flight with this scanner at a very precise rate, down to 1 to 2 centimeters X, Y, and Z. The vertical feature configurator, which I talked about earlier, this is where you can actually change the scan angle of the scanners like the Minivox 3 and the Vox 1 UAV, and actually scan certain areas like down towards a bridge or buildings and whatnot, and actually focus the laser points in an area that you want the most detail. So if you wanted to map around this bridge, instead of just flying simply above it, you can fly along the side of it and actually throw points to the left or to the right to actually get data up in those details, like even in some cases up under the bridge, like you can see over here. So this is a unique tool that Microdrones has that allows for you to change the firmware of the scanner in order to focus the point density in certain areas. Lastly, MD Infinity is our ecosystem to actually process all of your data, be it the trajectory processing, the georeferencing of the LiDAR data, and a lot of the different tools that needs to go hand in hand with LiDAR data, like strip adjustment, precision enhancement, ground classification, and even some more coming down the road, like FORMAP, which stands for Fast Ortho Mapping. But the big benefit of MD Infinity and everything about it is the flexibility of how you can actually purchase the hardware and also choose the different plans that actually go along with it. So make sure you touch base with Miles after this, and he can actually go into a little bit more detail on the different plans that go along with MD Infinity and how you can actually purchase these systems to actually process the data from these particular systems. And actually, to touch on too, just a quick little bit of the workflow when it comes to processing a LiDAR UAV-based LiDAR system. Essentially, you have a base station that's going to be logging static data throughout the flight. So when you get on site, you'll set up a base station, log static data at a 1-second interval. The drone's going to record all that data as well. So once you land and you finish flying for the day, you'll take the RANX file or the T02, T04 file from your Trimble base and actually marry it with the T04 file from the drone to produce what's called the post-process trajectory or where that drone was in 3D space throughout the entire flight. That then will be paired with the raw scan data and projected in whatever coordinate system you are working in. So we have all the NAD83 and various different coordinate systems that you need to work in your particular territory that's actually going to be able to produce the point cloud in the coordinate system that you're looking to work in. So that is hopefully I hit the mark and kind of showed y'all what y'all are hoping to learn about microdrones. What I'm going to do now is I'm going to hop in and show a quick data set through Trimble Business Center that shows what you can accomplish with a system like the LiDAR 1000. I'm going to open this up. So hopefully y'all are seeing Trimble Business Center now. What I have here is a data set that was flown out in Central Texas. If you remember earlier, I nicknamed the LiDAR 1000 the 1-foot contour generating machine, and I think you'll see why after I go through this data set. So in most cases, people are looking to utilize UAS LiDAR to help supplement their topographic workflow in areas like this. This was flown out in Central Texas, and here's a quick little snapshot of what it looked like on site. So you can see all the cedar trees and all the mess they had out there from the side, and here's another picture as well. So all the underbrush that you can see throughout this whole flight. So not only are you dealing with vegetation like this, Central Texas, you're looking at rattlesnakes, whole 9 yards. The customer actually estimated it would probably going to take about 2 weeks or even more of field time to actually topo this entire site by hand. It's about a 35 acre site, fully vegetated like you see here. So what we did, we got on site with them about 9 a.m., set up our base station to start logging static data, flew 2 flights. We flew a little lower and slower to make sure we had enough data we got enough data up under the tree canopy. After we were done flying, one of the surveyors on site actually went out there and took a couple check shots throughout the site in order to quality control the data. Once they were done, we broke down the base station, broke down drone, went eat lunch around noon, went back to the office about 2 o'clock, processed the point clouds that you're about to see, and brought it into TBC, extracted out the trees, produced the surface, produced the contours, all within the same 8-hour day. So something they said was about 2 weeks of field time. We did all within this same 8-hour day that you're seeing here. So this is the ortho produced from the 5 megapixel camera on board the drone. And you can kind of see the detail you're able to get up under, up around different areas like the truck. So it's going to be better than Google Earth gives you and whatnot. And then once we go into 3D view, I can actually turn on the point cloud and you'll see just this entire site. So there's just trees and vegetation everywhere. So right here in Trimble Business Center, if you open up the point cloud tab, they have this button called Extract Classified Point Cloud Regions. So if I click on it and open it up, it'll actually extract the ground, extract to different regions. In this case, we're just worrying about the ground. So I can uncheck everything but the ground, click extract, and then the software will go in and actually find the lowest points and give us what it thinks is the ground. It's not a magic button, but in most cases, it's going to get you down to what you're trying to accomplish. After it's done, this is what it looks like. So if you remember, we have all the trees on. Now they're off here. So just the ground alone, if I open up the properties, you're looking at about 8.2 million points. So if you try to build a surface with 8.2 million points, most engineers will send it back to you because it's just going to be really noisy and it's going to produce some pretty rough contours. So we can actually go into the point cloud region and click this button called sample region and say, I don't need 8 million points. I just want to point every 20 feet, or I don't point every 50 feet. And it'll actually build you a new point cloud based on those parameters you have set. So after you get done, you click store and you tell it what you want, and we can actually build a new point cloud with the data that we were interested in. So in this case, we got a point every 20 feet. So now we have 3,000 points, still way more data than we've ever would have shot in with a total station or a rover out there on site, but much more manageable. And some people like to take it from this point, export it out as a CSV, bring it into AutoCAD or Civil 3D, work with it in there, or you can finish up everything here in TBC. But I'll show you an example of what both those surfaces look like. So if I wanted the full surface, I can actually click on the Surfaces tab, highlight the point cloud, click Create Surface, and it'll actually build me a new surface with that point cloud. So here is the full ground that you can see right here. And like I said, when you try to build contours from this, they're going to be really noisy. And I'm sure if y'all have worked with photogrammetry data or whatnot, you've probably seen details like that. We can actually take and build a new point cloud with just the sampled ground and build a new surface. And this is a point every 20 feet. So something you're much more used to seeing, much more flowing. Still a ton of detail out there on site. And we can actually highlight this surface now, go into our Surfaces tab and click on Quick Contours. And we can build our 1 foot contours with this surface by simply just telling it, what layer and everything we want it on. And here we go. Here's our 1 foot contours. So if you remember, we went from this that you see here, all these trees and everything on site. So now we're looking at 1 foot contours of that particular area. Same thing goes, I like to show it in this view. You can actually see the 1 foot contours behind or with it, integrated it with the ortho. So you can see all the trees and the land flowing up under that vegetation. Pretty cool stuff. So the last thing we can actually do to make sure that our data is all matching, remember we took some check shots out there. So I can actually turn off our contours. We have some shots that we have out there. So they topoed up under the trees and some shots down here and along the road. We can actually take and highlight this particular area, click on the earthwork report, has a point to surface tab, and we click apply, and it'll actually build us a report letting us know, what the difference is trying to turn on my camera. I'm trying to move this out of the way. Shows us the delta, the difference in the surface created from the point cloud compared to the check shots that we had on site. So you'll have some outliers here and there. You'll need to go up and clean up the data. I wanted to show y'all what real world stuff looks like here. So you'll have some that might be 2 or 3 tenths off. In some cases, might be 4 tenths. You can go into the point cloud. It's typically where the surface triangulates over an area you might not have had all of it cleaned up on the ground. But typically, most of your check shots on a site like this, you're going to be about tenth and a half or so in the Z for that entire project. And that's going to give you, a way that you can actually quality control your data, compare it to, real world shots that you have out on site. And also make sure that if you see some spikes in the data that are out of tolerance, you can go in and clean up that surface to make sure that you are matching what the terrain actually is on site. So that kind of concludes my presentation on my side, kind of showing the different systems as well as the workflow through TBC, which you can do. Remember this project was something we said was probably about 2 weeks of field time alone, a week and a half. On a good week of actually going in and topoing this by hand, we knocked it all out in a single day. So being able to do something like this will really help you get a return on investment. When you start doing not one of these every couple of weeks, but one of these every day or every other day. I think that it kind of speaks for itself. So thank you guys and girls. I hope that it was time well spent. You learned a little bit something about microdrones. Miles, I guess I'll turn it back over to you.
Yeah, thanks, Matt. Thanks for sharing all that information. I guess now, I've seen some people with a few questions coming in. Let's see, and the first one, Matt, so a good one for you guys, is how is Microdrones complying, with remote ID currently?
Sorry about that, I was muted. Yeah, that's a great question. So actually our latest model, the version D model, the GE model that we just released and are delivering to new customers now is all remote ID ready. So we have it all configured to make sure that, as the regulations do become more strict and come into fruition, that those systems are ready to actually, are currently ready to actually to work with the new regulations of remote ID. So they are configurable currently in their current state.
Excellent. Thank you for that answer. Also we have a question here regarding, loading the KML files into MDCockpit. Could you touch, briefly just on that, as far as that feature and how that works?
Yeah, essentially, what you do is you have, I typically, when I'm loading a KML into MDCockpit, I'll email it to myself. I'll have like my Gmail account on my tablet, but you can also take, so it's an MDCockpit is an Android-based application for those who don't know, but essentially you can take, you can upload it from your computer, bring the KML file to a folder that you have set on your tablet. But essentially, if you open up MDCockpit, go to the, I think it looks like a little file folder on the top right hand. Open it up, click on Import KML, and you can navigate to that folder where you actually have your KML file and import it that way. And that's if you want to build a mission from it. But if you wanted to bring it as a layer, you would need to have it, and you open up your Layers tab, which is on the mission dashboard. And you open up Layers and navigate to that file, and you can actually open it up as a layer where you're not actually building a mission, but it's in the mission plan, so you can see it and actually build your mission from it.
Excellent. Thank you.
I saw another question from Josue as well about the different sensors too. I guess I'll touch on that one too. I'm sorry about that. I missed that one.
Absolutely. Yeah, feel free to outside what I was going to get to next. I think that's a good question.
My bad, Miles. Yeah, so you absolutely can. So if you wanted to start with the MDMapper 1000 DG, so you would start with the photogrammetry package. All those payloads that we showed you on the 1000, they're all, what's the word I'm looking for? You can go from one to the next very easily. So you can go from the high resolution camera to the HR or the LR LiDAR payloads very quickly. So you can absolutely start with one and then purchase the different payload down the road if you would like. So there's no additional hardware that you need to purchase other than the LiDAR scanner itself.
And another question here that we've got is, on the points to surface file that you were displaying, showing the overall accuracies with that MD1000 system, if someone was to fly the MD3000 over that same site, what would the differences be in the overall accuracy? I know that's kind of a tough question unless you fly it and see it, but on average, what would you think that improvement would look like?
What you'll see is a more refined, a more detailed surface. The differences between a 1000 type product and the 3000 type product is the quality of the scanner, right? So you have, the Veldine type scanners, they're going to be a little bit noisier. However, when it comes to mapping the terrain like you see here, it's going to give you very precise, in most cases is going to be very similar or even just as good as your rover shots on a land like this. So most of the time you're going to be about a tenth and a half or so on average with those systems. Whereas the 3000, you're going to be usually typically a tenth or less because of the precision of the laser scanner, as well as the thickness of the point cloud, or the amount of noise from the Regal scanners is much less. And you're going to get, especially on hard surfaces like you see on this side of the project, you would get more precise data as well. Typically you're going to be less than that, on those types of shots, with especially something like the Vux 1 or the Minivox 3.
Thanks. From my side right now, I don't really have anything else further to share. Matt, I think you did an excellent job covering the workflows and the different product lines. I'll give everyone a few moments here. If there's any additional questions, to please ask away, and we'll see if we can help get those answered for you. But if not, Matt, thank you for your time today, and everyone else, thank you for attending. We really appreciate it and giving us the opportunity to, essentially inform you of this solution and how it can help benefit your workflows on a day-to-day basis.
Yeah, I hope I hit the mark, everybody. And if y'all have any questions or like to get in contact with Miles or myself, I'm sure there'll be our contact info on the invite. But we look forward to continuing the conversations and if we need to hop on and do a little bit more detailed workflow through stuff like mdCockpit and others, we're more than happy to. So we look forward to working with y'all, and hope everybody has a great rest of your day.